Hey guys, welcome to Domain. In today's video, we are going to learn about the multi-threading. So let's start. So first we will see what is multi-threading. So multi-threading is like having a multiple workers in a kitchen. We will take a real life example. Okay. So multi-threading is like having multiple workers in a kitchen. A single threaded program is like a kitchen with just one chef who does everything: chopping, cooking, serving, one after another. A single threaded program is like one chef doing all the work. Okay, like chopping, cutting, then cooking, serving. Only one chef will do everything. That is nothing but the single threaded program. And then we have a multi-threaded program. The multi-threaded program is like kitchen having several chefs. One chef will do chopping, one chef will do uh, cutting, then one chef will do cooking, and another chef will do serving. We have multiple chefs. They will work together, and the whole process will be faster. Okay, obviously one single chef will be take more time to uh, chop, cook and serve. If there are multiple chefs, the work will be faster. Let's see some basic concepts. So first is thread. The thread is the smallest unit of a CPU that can perform in an OS. The thread is also a basic unit of an CPU, and it is well known for its independent execution. Okay. How we can create a thread in Java? So first is by extending the thread class itself and by implementing the runnable interface. Okay. So there are the two ways to create a thread in Java. Next is process. A program in execution that contains one or more threads. While execution of our program, if the program contains more than one thread, then that is nothing but the process. Then main thread. Okay, so the default thread that starts when your program runs, so that is our main method. Okay, so while execution of our code start executing from the main method. Okay, public static void main. So the public static void main, that is nothing but the main method, is also a thread. Okay, that is the default thread, we can say. Let's see why we use the multi-threading. Okay, so first it can be better performance. Okay, so our task or our process can be run simultaneously. Next, it can be responsive applications. So when your program does not freeze while waiting for other operations. So your program does not freeze while we wait for the other operations. Then next is efficient resource utilization. So while one thread waits for some operation, another thread can be work. Suppose there are multiple threads in a program and some threads are in waiting state. Other threads will be do its work properly. It will use the resources and it will utilize the resources very efficiently. Now let's see some challenges in multi-threading. So first can be race conditions. So when threads try to access shared data simultaneously, when we want to access the data simultaneously, then the multi-threading can be gets problematic. Then next can be deadlocks. Okay, deadlock like situation. So when the threads are waiting for each other forever, so that in that conditions also it is a challenge. Okay, then synchronization. So need to coordinate threads access to shared resources. Shared resources should be coordinate with the threads. Next is when we will see the multi-threading process. So first we will see web servers handling multiple requests. Suppose the result has been declared by the university or the boards, then multiple students try to access the same website by putting their seat number and mother's name. So on that website, multiple requests are coming. In that situation, we can see the multi-threading. Then we will see in mobile apps as well. So in bracket, I have written the keeping UI responsive while loading the data. Okay, while loading our data, the mobile app's UI should be responsive. So multi-threading is used here to keep our UI responsive.